ओके सॉरी, मैं म्यूट पे था. होपफुली आई एम ऑडिबल एंड विजिबल. स्टार्ट करते हैं आज की क्लास. हाउ आर यू गाइस? कैसा चल रहा है प्रिपरेशन नीट में? आई थिंक 1 वीक के आसपास ही मिला है. एक मिनट. या क्या कर रहा हूँ मैं? नीट में 1 वीक के आसपास ही बचा हुआ है. सो होपफुली द स्टडीज आर गोइंग नाइस. ओके, लेट्स स्टार्ट द क्लास. न्यू पेज, व्यू. ठीक है, होपफुली स्क्रीन दिखाई दे रहा है. व्हाट वी आर गोइंग टू स्टडी टुडे इज वर्क, एनर्जी एंड पावर. ठीक है, तो वर्क, एनर्जी एंड पावर होता क्या है ये समझते हैं. पहले तो वर्क सबने पढ़ रखा होगा. वर्क क्या होता है? वर्क इज बेसिकली, एक मिनट यार, इधर देख लो. वर्क, वर्क क्या होता है? वर्क इज बेसिकली हाउ मच displacement a force can produce. Okay, work is basically a quantity, how much displacement a force can produce. ठीक है, तो वर्क का फॉर्मूला क्या होता है? वर्क इज इक्वल टू फोर्स इनटू डिस्प्लेसमेंट इनटू कॉस थीटा. व्हाट इज कॉस थीटा हियर? कॉस थीटा इज बेसिकली द एंगल बिटवीन फोर्स एंड डिस्प्लेसमेंट. फॉर एग्जांपल, ये एक ब्लॉक यहाँ पे रखा हुआ है ऑफ मास m. I apply a force F and it moves the displacement of S. Okay, so what will be the work done due to this force? That will be equal to force times displacement, and the angle between displacement is in this direction, force is also is in this direction, so cos 0, which is 1. So F into D will be your answer. Hopefully this is clear. One more important thing I would like to tell you about work done is, work done is a scalar quantity. Work done is a scalar quantity. Work done is a scalar quantity because force, see here, force is vector quantity, displacement is also a vector quantity, and since we are applying dot product here, can I write this as force dot displacement, right? So since we are applying force dot displacement dot product, it's convert it into a scalar quantity, right? What is the unit of work done? Unit is joule. ठीक है, SI unit is joule, CGS unit is ERG, ergs. Okay, and what is the dimension of it? So force into displacement, force is MLT minus 2, displacement is L, so that will give you ML2 T minus 2, right? And okay, Hello. Sorry for the technical issue. कोई बात नहीं. We are going to start this. Hopefully the screen is visible. Yeah, I think the screen should be visible now. Yeah. If anyone wants to ask anything, they can just go ahead. और मैंने अपना पेन भी खो दिया. Very good. Where did I keep my pen? Just give me a sec, guys. Yeah, sorry for the delay. खैर, what was I saying? I was saying simply समझते हैं work done का dimension और unit Newton meter and the unit of torque are equal. तो question आ सकता है which of the following quantities और आया भी हुआ है similar question, which of the following quantities has the same dimension as let's say torque or work done. तो ऑप्शन दिया रहेगा ऑप्शन ए एंड दिस एंड टॉर्क. ठीक है, तो ध्यान रखना है वर्क डन का जो हमारा यूनिट है और टॉर्क का फॉर्मूला क्या होता है. टॉर्क इज इक्वल्स टू फोर्स आर क्रॉस एफ, राइट. आर एफ साइन थीटा. तो फोर्स न्यूटन वंस अगेन, मीटर साइन थीटा का कोई नहीं. तो दोनों का डायमेंशन देखो सेम आ रहा है, यूनिट सेम आ रहा है. होपफुली दिस इज क्लियर. दिस वाज एन इंपॉर्टेंट पॉइंट, राइट. अब आगे बढ़ते हैं. तो वर्क डन के बारे में एक और स्पेशल बात मैं बताता हूँ, लास्ट है ये. वर्क डन जब भी कैलकुलेट करने को बोले, फर्स्ट यू हैव टू आस्क फॉर व्हाट force we are calculating this work done. For what force, बहुत ज्यादा गंदी हैंडराइटिंग आ रही है, रुक जाओ. For what force we are calculating the work done. ठीक है, मतलब जब भी वर्क डन कैलकुलेट करने को तुमसे बोले तो हमेशा तुमको ध्यान रखना है, यू आस्क योरसेल्फ फॉर व्हाट फोर्स आर वी कैलकुलेटिंग दिस वर्क डन. ठीक है, होपफुली दिस इज क्लियर. आगे बढ़ते हैं. चलो, ये वर्क डन क्लियर है. वर्क डन का फॉर्मूला आई थिंक क्लियर हो गया. वर्क डन इक्वल्स टू फोर्स इनटू डिस्प्लेसमेंट इनटू cos थीटा. इट इज अ स्केलर क्वांटिटी एक्सेट्रा. आगे बढ़ते हैं. अब हम लोग देखने जा रहे हैं, एक क्वेश्चन करते हैं छोटा सा. ठीक है, क्वेश्चन मैं लिख रहा हूं, तुम लोग सब लोग सॉल्व करोगे. ऐसे क्वेश्चन आ सकते हैं, सिंपल क्वेश्चन. ठीक है, बॉडी इज डिस्प्लेस्ड, मेरे साथ साथ नोट करते जाओ. बॉडी इज डिस्प्लेस्ड फ्रॉम, एक ए का कोऑर्डिनेट दिया गया है 2,4, -6 टू बी का कोऑर्डिनेट दिया गया है 6, -4, 2, 6 -4 2. और पूछ रहा है और वैल्यू ऑफ फोर्स हम लोग को गिवन है 2i कैप प्लस 3j कैप माइनस k कैप. तुमको वर्क डन ड्यू टू ये वाला फोर्स निकालना है, वर्क डन ड्यू टू एफ. कैलकुलेट वर्क डन. तो जल्दी से ट्राई करो, 1 मिनट दे रहा हूं मैं. ट्राई दिस क्वेश्चन, फिर आगे बढ़ते हैं. ओके, होपफुली क्लियर, ये क्वेश्चन हो गया होगा. मैं सॉल्व करने जा रहा हूँ, देख लो. बॉडी का डिस्प्लेसमेंट दिया गया है, हम लोग टोटल डिस्प्लेसमेंट निकाल लेते हैं कोऑर्डिनेट से, फाइनल माइनस इनिशियल. तो आर वेक्टर क्या हो जाएगा, 6 - 2 दैट विल बी 4i एंड -4 दैट विल बी -8j एंड 2 + 6, देखो 2 -6 तो 2 + 6 दैट विल बी व्हाट डू यू से 8k. फोर्स हमारा ऑलरेडी दिया ही हुआ है, फोर्स वेक्टर 2i + 3j - k. दोनों का एक काम करते हैं, डॉट प्रोडक्ट ले लेते हैं डिस्प्लेसमेंट एंड फोर्स का, तो दैट विल गिव अस वर्क डन. तो 4 2 8 माइनस, देखो i का i के साथ मल्टीप्लाई कर देते हैं, i कोफिशिएंट एंड i कोफिशिएंट मल्टीप्लाई देम टुगेदर, 4 2 8 -24 एंड -8. तो दिस विल गिव अस 8 से 8 कट जाएगा, minus 24 joule. So what does negative sign represent here? That is very important thing to know. What does negative sign represent here? Negative sign represents the force we are applying that is opposite to the displacement. Means, for example, let's say a block is one force F1 and one force F2. दो forces लगाए मैंने, ठीक है, and block यहां से यहां चला गया. तो what can I say? क्या conclusion हम लोग निकाल सकते हैं इससे? कि पहली बात तो F1 is greater than F2. Yes or no? कि force 1 ज्यादा होगा, force 2 कम होगा, तभी वो उधर move किया. First thing. Second thing हम लोग क्या बोल सकते हैं कि जो वर्क डन ड्यू टू F1 होगा विल बी ग्रेटर देन 0. वर्क डन ड्यू टू F1 विल बी ग्रेटर देन 0 क्योंकि फोर्स भी इधर लग रहा है एंड वर्क डन भी इधर हो रहा है. एंड तुमको फील नहीं हो रहा कि F2 जो है अपोज करेगा इस जो भी हो रहा है. तो वर्क डन ड्यू टू F2 विल बी लेस देन 0 यानी कि नेगेटिव, क्योंकि फोर्स इधर लग रहा है, डिस्प्लेसमेंट ऑपोजिट डायरेक्शन में. होपफुली नेगेटिव वर्क डन का कॉन्सेप्ट क्लियर हो गया होगा. नेगेटिव वर्क डन मींस वी आर अप्लाइंग एनर्जी बाय दैट फोर्स इन रेजिस्टिंग समथिंग. ठीक है, आगे बढ़ा जाए. अब देखो, वर्क डन निकालने के लिए तीन टाइप के क्वेश्चन आते हैं. इफ यू वांट टू कैलकुलेट वर्क डन, if you want to calculate work done, then three type of questions are asked in NEET exam. ठीक है, वर्क डन निकालने के लिए three type of questions have been asked, are being asked. First is constant force. फॉर एग्जाम्पल जैसा अभी अभी क्वेश्चन किया था हम लोगों ने, इसमें कांस्टेंट फोर्स था, फोर्स का वैल्यू कांस्टेंट था एंड वी हैड टू कैलकुलेट द वर्क डन. तो कांस्टेंट फोर्स के बाद ऑब्वियसली क्या आएगा? वेरिएबल फोर्स. तो व्हाट विल बी डू इन वेरिएबल फोर्स विल स्टडी. ओके, लास्ट इज एरिया अंडर द कर्व. एरिया अंडर द कर्व. ठीक है, कांस्टेंट फोर्स का अभी एक क्वेश्चन कर चुके हैं. वेरिएबल फोर्स में क्वेश्चन कैसा दिखाई देगा मैं थोड़ा सा एक आइडिया दे देता हूं तुम लोग को. एक क्वेश्चन करके हम लोग देख लेते हैं. ठीक है, क्वेश्चन है फॉर वेरिएबल फोर्स F इज गिवन एज एक्स स्क्वायर आई कैप प्लस 2x जे कैप. ठीक है, और तुमको क्या निकालना है? और dr, एक काम करते हैं, F इज गिवन एज एक्स स्क्वायर. चलो ठीक है, सिंपल रखते हैं. एंड r का वैल्यू हम लोग को बताना. देखो F जो है वेरिएबल ऑफ x है, मतलब कि x इज अ वेरिएबल, राइट? F इक्वल्स टू एक्स स्क्वायर. एंड हम लोग को जो है डिस्प्लेसमेंट दिया गया. यू हैव टू फाइंड द वर्क डन. यू हैव टू फाइंड द वर्क डन सच दैट बॉडी मूव्स फ्रॉम क्या कहते हैं ओरिजिन. बॉडी मूव्स फ्रॉम ओरिजिन टू 2 meters इन एक्स एक्सिस. मतलब लेट्स से ये कोऑर्डिनेट सिस्टम है, तो ओरिजिन से 2 meters जाने में इस फोर्स की वजह से कितना वर्क डन होगा, ये चीज निकालना. तो वेरिएबल फोर्स के लिए ध्यान रखो, हम लोग फॉर्मूला क्या यूज करते हैं? वर्क डन इज इक्वल्स टू F डॉट dx. ठीक है, F डॉट dx. अच्छा, ये फोर्स सिर्फ और सिर्फ देखो आई कैप में बोल रहा हूं, तो फोर्स सिर्फ और सिर्फ किस में एक्ट कर रहा है? आई डायरेक्शन में, राइट? हम लोग को जो है क्या निकालना है? एक्स एक्सिस में निकालना है. तो डायरेक्ट फॉर्मूला लगा दो. सोल्यूशन वर्क डन इज इक्वल्स टू इंटीग्रेशन फोर्स इनटू डिस्प्लेसमेंट. और सिंस यहाँ पे वेक्टर लगा है दोनों पे, वेक्टर का क्या मतलब है? यहाँ पे फोर्स इनटू डिस्प्लेसमेंट इनटू कॉस थीटा. कैन आई से डॉट प्रोडक्ट है तो कॉस थीटा लगा देता हूं मैं. अच्छा, सबसे पहले फोर्स बताओ कितना है? एक्स स्क्वायर. किस डायरेक्शन में? आई कैप डायरेक्शन में, राइट? आई कैप मतलब एक्स डायरेक्शन में. लेट्स से ऐसे. हम लोग को जो डिस्प्लेसमेंट देखना है वो भी तो ऐसे ही है ना. चेक करो, 0 से 2. फोर्स देखो एक्स एक्सिस में लग रहा है क्योंकि आई कैप लगा हुआ है. यहाँ पे देखो आई कैप लगा हुआ है, इसलिए फोर्स इज इन एक्स डायरेक्शन, पॉइंटिंग इन दिस डायरेक्शन. डिस्प्लेसमेंट भी हमारा इसी डायरेक्शन में है ना, बिकॉज 0 से 2 जाना है हम लोग को. देखो ओरिजिन से 2 meters. तो यहाँ पे क्या मैं बोल सकता हूँ कि ये भी क्या कहते हैं, ये आई कैप था तो ये dx आई कैप ही होगा. या तो आई कैप के टर्म्स में लिख लो, या तो एंगल बताओ कितना होगा दोनों के बीच में. एंगल विल बी 0, राइट? तो एक्स स्क्वायर dx एंड cos 0 is 1. तो उसको हटा दिया मैंने. अब लिमिट बताओ क्या होगी? कहां से कहां तक जा रहे हैं? 0 से 2. x में 0 से 2. तो आई थिंक अब तो सॉल्व हो जाएगा. एक्स क्यूब बाई 3 0 से 2 दैट विल बी इक्वल टू आई थिंक 8/3 जूल. होपफुली दिस इज क्लियर. वेरिएबल के क्वेश्चंस हो जाएंगे. 3 चीजें ध्यान रखनी है: फोर्स, ठीक है, डिस्प्लेसमेंट एंड उन दोनों के बीच का डायरेक्शन. फोर्स डिस्प्लेसमेंट दोनों के बीच का डायरेक्शन एंड देन इंटीग्रेट. फोर्स डिस्प्लेसमेंट दोनों के बीच का डायरेक्शन एंड देन इंटीग्रेट. होपफुली वेरिएबल वाला क्लियर है. कांस्टेंट फोर्स क्लियर है, वेरिएबल फोर्स क्लियर है. ये फॉर्मूला प्लीज नोट डाउन कर लो, इंपॉर्टेंट है. ठीक है, लास्टली एरिया अंडर द कर्व, अगर हम लोग को देखो वर्क डन का फॉर्मूला हम लोगों ने पढ़ा है ना, वर्क डन इक्वल्स टू फोर्स इनटू डिस्प्लेसमेंट, राइट? तो फोर्स और डिस्प्लेसमेंट को मल्टीप्लाई करने पे वर्क डन आता है। ये क्या कहते हैं, मोटी मोटी सी बात समझ में आ रही है। अच्छा एक चीज मेरे को इंग्लिश में पढ़ाने की हिंदी में मैंने देखा। ओके ओके, सॉरी 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 लोगेश, I forgot I had to take the class in English, but okay, let us just revisit what we studied. Okay, I'll translate everything now. First, there are three ways to solve work done questions. First is when the force is given as constant. For constant force, we solve this question right here. The force was given as this and it was constant, and we have to calculate the work done. So we directly applied the formula F dot R. Is that clear? Secondly, if the force is given as variable, for example, F is equals to x square. X is a variable, right? X can vary from 0 to infinity, right? So X is a variable. So you have to calculate the work done for this force from 0 to 2 meters. So we use integration method, integration F dot dx. First, substitute the value of F dx because we are talking about X axis. And the angle between these two, since it is also in x-axis, displacement is also in x-axis, the angle between them will be 0 degree, right? So cos 0 will be 1. So x square, now integrate, what will be the limit of this integration? 0 to 2. See, 0 to 2 will be the limit. So 0 to 2 x square dx, x cube by 3, substitute it, you'll get the answer 8 by 3 joule. Hopefully this is clear to everyone, right? Now, lastly is area under the curve. The question very frequently asked. If you see the previous year question paper now, you'll get to know a lot of question has been asked from this area under the curve. Okay? So what is area under the curve, sir? It's very simple. The what do you say? The graph will be given between force and displacement. So whenever a question gives you graph and asks you work done, so always you have to make sure you check the forces on y-axis, it should be force, and in x-axis, it should be displacement. Okay. Now, if this criteria is matched, what you can do is, for example, this is the graph given. Okay. Now you have to calculate the work done by this force using this graph. You have to do nothing. You just have to calculate the area under this graph. So this is the area under this graph. Now, for example, this coordinate is 0, 0. This is given as 1, 0. And this coordinate is given as, let's say, 0, 2. So can you calculate the area under this graph? I think you all can do that, right? So it will just simply mean that's the answer. So what will be the area? Work done is equals to area is half base. How much is base? 1, height 2. So 1 joule will be your answer. Hopefully this is clear. I know this type of simple question won't be asked, but how will they ask? In 2019, I think they asked a question where they just gave a graph like this, something like this. Okay, and they gave the value of this and this, this and this, and they wanted us to calculate the work done. So I think this is pretty simple. You can calculate the area of this one, this part, this rectangle, this triangle, rectangle, this triangle, and this rectangle. You'll find the area between under this curve, and once you find the area between, that is the work. Hopefully this is clear to you, right? Clear, right? So area under the curve, I think question would be easier. Now, what is the main crux to be understood from this is on x-axis and y-axis, it should be it should be displacement, and in y-axis, it should be, what do you say, force. Hopefully this is clear, right? Now, let's move on. Let's move on to next topic, which is conservative and non-conservative forces. A lot of assertion reason question can be asked from this topic. Acha, hope is everyone comfortable with the language now? I'm really sorry if that was a problem back then, but are you guys comfortable with the language? If you have any issue, you can let me know, sir. I'm not getting this point or I'm not getting that. Okay, thank you very much. Thank you. Let's continue. Conservative and non-conservative forces. Non-conservative forces. First of all, you have to make sure conservative and non-conservative forces. I know my handwriting is worst, but I'm using a new pen tab, so Please hang in there. Okay. Conservative and non-conservative forces. What are conservative and non-conservative forces? There are certain qualifications you should have to be for a force to be called a conservative force. What are those qualifications, sir? First thing, see, very important. First thing, for example, I'll explain it here. Huh. So first very important point is work done is path independent. For example, if I go from, let's say, this is point A and this is point B. If I go in this direction using this path 1, okay. If I go using this path 2, if I go using this path 3, in all the cases, if I'm applying a conservative force and displacement is happening and initial and final points are same, then I can say the work done is the force which we applied is conservative. If work done 1 is equals to work done 2 is equals to work done 3. See, the work done does not depends on the path, right? Work done are same in all the cases. So then we can say the force which we apply for moving a body from A to B is conservative. The force which we apply from moving a body from A to B is conservative. Hopefully this is clear, right? So work done is path independent. Okay, it does not depends on the path. So on what factor does it depend then, sir? It depends on the initial and final points. If the initial and final points are same, then the work done is same. Okay, it depends. What depends? Work done by a conservative force. Work done by a conservative force depends on initial and final points. Hopefully this is clear. Should I move on? Okay. The term potential energy or potential energy or potential is only defined for conservative forces. Hopefully this is clear. The term potential energy or potential is only defined for conservative forces. All right. So that's why when you studied electrostatic force, so you also studied potential and potential energy. You studied gravitational force. Then you also studied gravitational potential and gravitational potential energy. What does it say about gravitational force? That means gravitational force is a conservative force and potential energy is also a electrostatic force is also a conservative force. Hopefully this is clear to everyone, right? It's clear, right? Gravitation. What are the examples of this? Example, gravitational force, gravitational and electrostatic, spring force. These are all conservative forces. What are the example of non-conservative forces? For example, a block I take, okay, I take it from A point to B using this. It is lying on a surface, let's say, from A point to B using this direction and this direction. And since the surface has a friction, so obviously work done from A to B using this path first will be less as compared to second, right? So we can say friction force is a non-conservative force. Hopefully this is clear. What is spring force? Okay, I'll tell you. Okay, let's talk about spring then. For example, this is spring. Okay, you keep a block. Okay, you keep a block on it and you try to pull the block this side. So what will happen? This is the equilibrium position. What will happen? The spring will get stretched, right? Now you're holding that spring. Now you're holding that spring like this. Okay, so you have to apply certain force, right, to keep it here in this direction. Why is that? Because spring is applying another force to pull it back to its normal length. Spring always wants to be in its normal length. Okay, you stretch it, it will try to compress itself by applying a force called spring force. Okay, you try to, what do you say, compress it. It will apply another force in opposite direction to release itself. It's clear, right? What is spring force? If you stretch a spring, the spring will apply a force that is called spring force. And that force, what if I, let's say I bring this till this distance x, and next time I bring the spring more, I stretch it more till 2x. In which condition, in x or in 2x, in which condition will be the force due to spring will be more. I think 2x, right? The more you stretch the spring, the more it will, try to pull it back. So इसीलिए F is directly proportional to X. What is X? X is the displacement in the change in length, change in the natural length. X is, I'll write it down here, change in natural length of spring. Hopefully this is clear to you all, right? Okay, if the spring, and minus x, since I'm applying force here, and since the spring is applying force in this direction, I'm applying force in the right, spring is trying to apply the force in left, right, and displacement is happening. This means displacement is happening in right, and spring is trying to pull it back, right? Opposite. That's why negative sign we use here. Okay, so F is equals to minus kx. Hopefully this is clear. Now, work done we can calculate, since this is a, what do you say, variable force. So Fx dx, if you calculate it, you'll get F kx square by 2 x square minus x naught square. Very important. Note it down. The work done due to a spring. I'll write it down here. Work done due to a spring, half k x square minus x naught square. Just note it down, guys. Very important. We'll solve a NEET question related to this. Okay. Just note it down. We'll solve a NEET question. Hopefully this is clear, right? Okay, let me just open the question. This is from 2022, last year. All right. The question is, I'm writing down the question. Work done in stretching spring. The work done in stretching spring from natural length to x is W1, and from x to 2x is W2. Then options is given as W1 by W2 is equals to 2:1. W1 by W2 is equals to 3:1, 1:3, and D 1:2. I'll explain you the question. This is from NEET last year, 2022. Work done in stretching string from natural length to x, means from natural to x is W1, and from x to 2x is W2. So let us just draw a diagram, right? Diagram will, explain you a lot. For example, sorry. So let's say this is the natural, all right? In first case, what we are doing, in first case, this was the natural length. We are just stretching the string to a distance of x, right? In the second case, what we are doing, we are stretching it further to a distance of, from natural length, this was x, and from x we are further turning it up to x, means stretching it more x, right? I hope this is clear. Diagram is clear, hopefully. Now, from going from here to here, what will be the work done? I'll write down here. Work done. Work done is half k x square minus x naught square. What is x square, sir? X square is the final position, final distance. What is x naught? X naught is the initial distance. Like that you can think. So half k x square. So for in this case, it was at, see, initial point 0, and it went to a distance of x. So can I say x square minus 0 square? See, final point is x, initial point is 0, right? So half k x square is work done first. What about work done second, sir? Half k, same, it will remain same. K is spring constant, by the way. Okay? So initially it was here, finally it went here. So it went from x to 2x. So can I say 2x whole square minus x square? So this will give us, I think, 3k x square by 2. What will be the ratio of 1 and 2? Work done by 1 and work done by 2. That will be equal to half k x square divided by 3 by 2 k x square. I think half will get cancelled out. Kx square will get cancelled out. 1:3. So which answer is it? 1:3. That is option C. Hopefully this is clear to you all. This formula is clear. What is x? X is the final distance which we are taking. What is x naught? X naught is the initial position of that spring. Clear? Does anyone has any problem in this question? Please let me know. Spring force, is spring force clear? Okay. Can you guys tell me where are you guys from? Means from Karnataka or where? Just a question, just to know you guys better. Tell me. Manipur. Okay. Nice. My aunt lives in Manipur. Okay. So is my English clear, right? Because my English is very bad. Okay. So I mess up with grammar a lot. So if there are some grammatical errors, please forgive me. Okay. Thank you. Thank you very much. Okay, let's talk about something called kinetic energy. You know, I know since class 9th, 10th, you're studying kinetic energy. Formula is half mv square. Some of few things which might be important for NEET that I'll tell you. Kinetic energy is always a positive quantity. Okay, kinetic energy can be 0. Kinetic energy can be positive, +1, +2, plus 2.5, anything. But kinetic energy can never be negative. Okay, kinetic energy is never negative. So this relation can be asked. Which of the following relation is true? And one of the option will be this. So this one is true. Hopefully this is clear to you all, right? Kinetic energy is always positive or 0. It can be 0 or positive, but it can't be negative. So let me ask you a JEE advanced question. All right. With this same logic, you can answer a JEE advanced question. Region 1, region 2, region 3. This was the displacement and this was kinetic energy. As the particle goes, which of the following region is not possible? The question was, which of the following region is not possible? 1, 2, 3, or all of the above. So see, kinetic energy in this one is positive, right? Kinetic in this region is also positive, but in this region, kinetic energy became negative, right? So region 2 is not possible. Hopefully this is clear. Is this question clear to you all? Right? Okay. So let's move on. Let's move on to work energy theorem. Work energy theorem. What is work energy theorem? It's very simple. Okay, a quick recap. Which of the following forces have a potential associated with it? Conservative force or non-conservative force? So the answer is conservative force. Always conservative forces have potential associated with them. If there is a conservative force, there is a potential. We can calculate potential of it. If the force is not conservative, we can't calculate. Okay, recap over. Let's move on. Work energy theorem. What does work energy theorem says? Total work done, net work done or total work done is equals to change in kinetic energy. Very important, very easy. Total work done is equals to change in kinetic energy. Hopefully this is clear. Let me give you a question related to this. All right. This is from NEET 2016. NEET 2016 question is in front of your screens. A bullet of mass a bullet of mass 10 gram leaves a rifle, okay, at an initial velocity of 1000 meter per second. A bullet, mass 10 gram, initial velocity 1000 meter per second. Okay. Strikes the earth at same level at velocity 500 meter per second. I'll explain you the question. Okay, let me just write it down. The work done by air resistance is, oh my god, sir, in physics we neglect the air resistance, right? Why is this question asking us to find the work done due to air resistance? Because we don't have to find it directly, we will do it indirectly. Okay, so the options are 375 joule, 3750 joule, 5000 joule, and 500 joules. Okay, so how do we solve this? This is from 2016, NEET 2016. So let me just read the question. A bullet of mass 10 gram, initial velocity 1000 meter per second, strikes the earth at the same level at 500 meter per second. For example, this is our bullet. Okay, it leaves the rifle. This is not a rifle, it's a handgun, but okay, my drawing is very bad. So it leaves it and after same level, on the same level, it hits something at a speed of 500 meter per second. It leaves at 1000 meter per second and it hits at 500 meter per second. So obviously air is resisting it, right? Whoa, if air is resisting it, we have velocities and we want to find, what do you say, work done. We have velocities and we have to find work done. So always remember, if you want to find work done and you some sort of have velocity, then use work energy theorem. All right, what is work energy theorem, sir? Total work done, F net, is equals to change in kinetic energy, right? Before coming to total work done, can I say work done? What is change in kinetic energy? Change in kinetic energy means mv square minus half mu square. Half mv means final velocity minus half mu means initial velocity. Total work done. Who is doing work? What are the forces acting on this? Only a resistance force, means the bullet is moving in this direction and a force is opposing it, right? No other force is acting on it, right? So work done due to friction. Hopefully this is clear. Work done due to friction force, opposing force, is equals to half mv square, half mu square. What if question would have said a 10 Newton force is also acting? So we should have we have to calculate the work done, have to write work done due to 10 Newton like this. But in this case, it's not asking and it's not going to ask in future as well. Work done due to F is equals to half mv square minus half mu square. Hopefully this is clear. Can I take half m common, v square minus u square, just to simplify the calculations? Half 10 grams. Can I convert 10 grams into kgs? Divide by 1000. V, final velocity is 500 meter per second minus initial velocity is 1000 meter per second. Square it, solve it. What will you get? We'll get 0, 0 gets cancelled out. 1 by 200 into 25, 1, 2, 3, 4 minus 1, 1, 2, 3, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, let me simplify. Can I take 4 zeros out? Okay, so 1, 2, 3, 4 divided by 200. 25 minus, I think, 100. 25 minus 100 will be close to 75. Zeros and zeros will cancel out. 100 divided by 2 into 75 minus 75, right? 2, I'll just simplify this. 2 3s are 6, 7.5. So 3750 joule. Which option it is? 3750 joule, option B. Hopefully this is clear, right? Simple. If velocity is given, you want to find work done, just remember work energy theorem. What is this W net here? W net means total work done. Total, first calculate total forces acting on it and work done due to each force. Is this clear, everyone? Is this clear? Should I give one more question related to this from NEET 2017? Okay, thank you very much. Only one person is responding. What about Dhruvi, Ritu, Logesh. Yes, WF is work done due to friction force. I'll give you one more question. Try that and let me know if you get that or not. All right. The question is on your screens now. The question is, consider a drop. Wait, I'll just show you guys the question, right? That would be far easier. The question is, consider a drop of. So this is the question you have to solve. Just try solving this. These are the 4 options. Consider a drop of rainwater having mass 1 gram falling from a height of 1 kilometer. So the displacement is given as 1 kilometer, right? I'll just write it down. Mass 1 gram, height 1 kilometer. It hits the ground with a speed of 50 meter per second, means final velocity is given. And water droplet, initially it has velocity 0, right? Final velocity we have 50. Okay. Value of G 10. Thank you, God. They gave us 10. The work done by gravitational force and resistive forces. So try to calculate it. Try to calculate it, guys. Come on. And then I will calculate after that. Don't worry. I'm giving you 2 minutes to try to solve it. I'm giving you a hint. Work done due to gravity, force due to gravity into displacement into cos theta. Just use this formula. Okay, my turn. I'll solve it. I'll solve this question. Work done due to gravity, force due to gravity. This is a drop. I'll just make this. Okay. So 1 kilometer means 1000 meter it's falling. Initially its velocity was 0. Finally its velocity is given as how much? 50 meter per second. Just before fall, right? It is following like this. So what is the force on it? Can you tell me force due to gravity? That will be mg, right? So mg. Displacement, how much displacement it is giving? Doing 1000 meters, right? Into cos theta. Force is acting in downward direction. Displacement is also acting in downward direction. So cos theta is equals to 0 degree. So cos 0 is 1. Hopefully this is clear. What is m? M is 1 gram. 1 means 1 by 1000. Into g is, luckily they gave us, take the value 10, right? So we'll take 10 into 1000. 1000 will cancel out. 10 joule. That is the work done due to gravity. So which of the option is correct? I think option A or B. In these two, anyone might be correct, right? Okay. Now, tell me resistive force. I can, without calculating, I can give you the answer. Resistive force, it's resisting, right? So force will be opposite. Work done will be also be negative, right? So work done, which of the following has negative work done? I think option A. So option A is correct. You don't even have to solve the option, Yeah, very good, very good. Correct. The answer is A. Okay. What if there were 2 negatives? So we have to solve it, right? So how to solve this? First of all, have you guys noted this down? Should I erase it? Okay, I'll erase it now. Okay. So, okay, thank you. Now, let me just, what was I saying? work energy theorem, right? Okay. So total work done will be due to gravity on this. Work done will be due to gravity, and work done will be due to a resistive force, air resistance, right? Two forces are acting, gravity and air resistance. Friction, I'm writing it as friction, is equals to change in kinetic energy. Can I apply this formula? Work done due to gravity, I just calculated. Work done due to friction, I have to calculate. Change in kinetic energy, half mv square minus u square. 10 plus wf is equals to half m means 1 by 1000. V is velocity due to final velocity, that was 50 meters square, and initial velocity 0 square. Hopefully this is clear. Now when you solve this, you'll get your answer minus 8.75 joule, which is option A. Hopefully this is clear, right? How to use work energy theorem, is that clear? Okay, Logesh, thank you. Now, let me just tell you one last thing, then we'll wrap up this class, okay? Okay. All right. So last thing is power. What is power? So I'll tell you two things about power. First of all, power you have studied already, work done by time, right? What if I write work done as force into displacement by time? What is displacement upon time? Can I say it is, what do you say, velocity? So there are two formulas for power, work done by time or force into velocity. Now, a lot of questions in NEET are from this formula. Force into velocity. It will give you a force, it will give velocity, and you have to find what is the vector form of this formula. Power is equals to force dot velocity. Hopefully this is clear, right? So note this down and try to solve questions regarding work done. Okay, you can, I'm telling you, if you focus a little bit more, you can solve a lot of questions using kinetic theory of gases, work done by variable force, work done by area under the curve, etc. If I show you, I don't think so it is visible. There is a question in which a graph is given like this. The graph is like this, and they have given this values. This is 2, this is 3, 7, and 12. Here it is given as force, either displacement. You have to calculate the work done. So how simple can this be? This is a 2019 NEET question. All right, a lot of similar questions have come. So just solve questions and you'll get to know. Hopefully this is clear. Do you guys have any doubt regarding today's class? Can let me know. Two people are there in the class, Dhruvi and Chijuni. I'm sorry if I pronounce your name wrong. By the way, my name is Faiz. Just class. I'm giving my introduction at the end of the class. Very good. Okay, so we'll wrap up this class now. If you have any doubts, just ask me in the next class. All right. Have a good day, guys.